Hey everyone, in this video we'll be learning the point-slope form of a line. In my opinion, this is the most efficient way to write the equation of a line because unlike slope-intercept form where we have to have the y-intercept, point-slope allows us to write the equation using any point on the line. So in order to start, we'll review the slope formula, which is m equals y2 minus y1, change in y, over x2 minus x1, change in x. So they ask us to find the slope between the points x1, y1 and xy. So our slope there is going to be y minus y1 over x minus x1. And then it tells us to cross multiply. So I'll write m over 1 and we'll cross multiply, which is going to give us 1 times y minus y1 is y minus y1, and then m times x minus x1 will be m times the quantity x minus x1. Now, in this example, xy stands for some general point, x1, y1 is a specific point. So if we manipulate the slope formula, we wind up with this equation. This equation right here is point-slope form of a line. So to define it, point-slope form of a line, y minus y1 equals m times x minus x1, where m is the slope of the line and x1, y1 is a point on the line. So as we can see, it can be any point on the line. It does not have to be the y-intercept. So state the point and slope of the following lines. So the first line, y minus 5 equals 3 times x minus 1. So our slope, which again is m, that's the coefficient here, which is 3. And then the point, in this case, so just to point out, the signs here, it's x minus x1, y minus y1. Right, and the point is x1, y1. So if we have x minus 1, then the x-coordinate of the point is 1, and y minus 5, the y-coordinate of the point is 5. Okay, so the sign is one of the challenging things when we're pulling the point out of the equation. Okay, so in this case, x minus 1 means the x-coordinate is positive 1. Y minus 5, the y-coordinate of the point is positive 5. Now if we look at our next example, y plus 2 equals negative 3/4 times x minus 7. So our slope is negative 3 over 4, and our point, so x minus 7 means the x-coordinate of this point is positive 7, and then y plus 2, we can think of this as y minus negative 2, so that the form matches up above, right, where we have subtraction. So then the y-coordinate of the point is going to be negative 2. Now, it may seem counterintuitive that we have x minus 7 in our parentheses, and we're stating that the x-coordinate of our point is positive 7. But later on in this course, we're going to learn about transformations, which are going to help us make a lot of sense out of why that is true. Okay, but for right now, we just have to understand that the definition is y minus y1 equals m times x minus x1. Right, so we have subtraction in our definition. So then we're looking at this value. If we have x minus 7, this value here is the x-coordinate. If we can do this successfully, that is pull out the slope and the point from point-slope form of a line, then we have the only two pieces of information that we're going to need in order to graph the line. Write the equation of the line with the following properties. A slope of 3 through the point negative 6, 10. So now let's go in the reverse direction. They've given us the slope and they've given us a point. Now let's write the equation. So just to refresh our memory, y minus y1 equals m times x minus x1 is point-slope form. So here, y minus 10, right, that's our y value of the point, equals 3 times x minus negative 6. So if we simplify it, y minus 10 equals 3 times the quantity x plus 6. Now let's suppose that they wanted us to take the point-slope form and see if it's equivalent to slope-intercept form, right? They've given us another equation. Well, that's actually pretty easy for us to do from point-slope form. All I'd have to do, and I'll use a different color and come over here, I'd start by distributing the 3, so we'd have 3x plus 18, and then add 10 on both sides, and we'd have y equals 3x plus 28. So that's another advantage of point-slope form of a line. Even if we needed to state our answer in slope-intercept form, or maybe it's a multiple choice question where all of the answers are in y equals mx plus b form, all we have to do is take our point-slope form and simplify it, and we come up with slope-intercept form. Okay, whereas if we start with slope-intercept form, y equals mx plus b, would be much more of a challenge to try to go back, if not near impossible. Okay, so that's another reason why point-slope form is more effective than slope-intercept. So looking at our second example, a slope of -1 through the point 2, -1. So we have y minus -1, the y coordinate is -1, slope is -1, and then x minus 2. So simplifying, we'd have y plus 1 equals -1 times x minus 2. And we can leave our answer just like above. We can leave it right there. Okay, this work to the side was just to show you that I can put this equation in slope-intercept form. But if we're coming up with an answer in point-slope form, we're done right here. Or in this example, right here. Okay, that's another nice feature of point-slope form. So write the equation of the line between -1, 3 and 4, 1, and then graph the line. So we have 2 points, we're missing a slope. So we'll start by finding the slope. So 1 minus 3 over 4 minus -1. That's going to be -2 in the numerator and 5 in the denominator. So our slope is -2/5. So point-slope form, we need a point and slope. So we already have our slope, we have 2 points here. So the decision is ours. We can write the equation using either point. So let's say we use -1, 3 as our point. So we'd have y minus 3 equals -2 over 5, x minus -1, which becomes y minus 3 equals -2 over 5, x plus 1. Let's suppose you chose the other point. So I'll use blue. So let's say you chose the point for 1. So your equation would look like y minus 1 equals -2 over 5, x minus 4. Now, both these look different, but they define the same line. And if you really wanted to convince yourself of that fact, simplify both of these to y equals mx plus b form, the green equation and the blue equation, and what you would find is that they are the same. So we can then graph. So let's graph using the point -1, 3. So we plot -1, positive 3, so there's our point. And once we have that initial point, we use our slope to define the rest of the points on the line. So down 2 to the right 5, down 2 to the right 5, and then going the other direction up 2 to the left 5. And we can then connect our points to create our line. Okay, so there we have the graph of, I'll write the green equation, y minus 3 equals -2 over 5, x plus 1. Okay. Write the equation of the line between -4, 3 and 8, 6. So 2 points, we're missing a slope. So we can use the 2 points to find the slope. So 6 minus 3 over 8 minus negative 4. We have 3 in the numerator and 12 in the denominator. So a slope of 1/4. Now we can use either of these points. So if we use the point negative 4, 3, our equation, y minus 3 equals 1/4 x minus negative 4, which can be simplified to be y minus 3 equals 1/4 x plus 4. And if we wanted to use the point 8, 6, we'd have y minus 6 equals 1/4 x minus 8. Now, in both the previous slide and this slide, I wrote both equations. You don't have to. All you would have to do is choose one of these points with your slope and write one of these two equations, okay, to come up with your answer. I'm just showing you both of them to show you that you can use either of these 2 points. Now, graphing the line, so we'll plot the point negative 4, 3, and then a slope of 1/4, so up 1 to the right 4, up 1 to the right 4. And if we want to go down 1 to the left 4, and we'll connect our points to create our line. So there we have the graph of y minus 3 equals 1/4 x plus 4. So now, given the equation of a line in point-slope form, we have to work in the reverse direction, right? So the previous 2 examples, we created the equation. Now we have to pull the information out from our equation. So start with the easy part, which is identifying the slope. That's the coefficient here, which is negative 1/3. And then we need to define our point. So remember, I'll write it here. Again, just to emphasize this. The point-slope form of a line is y minus y1 equals m times x minus x1. So we have x minus 2. So 2 is our x-coordinate. And then we have y plus 4. Right, so that's the same as writing y minus negative 4. So the y-coordinate of our point is going to be negative 4. Right, trying to match up the equation with the definition. So now we can plot the point to negative 4. And we have a slope of negative 1/3. Up 1 to the left 3, up 1 to the left 3, up 1 to the left 3. And now we can connect our points to create our line. I'll adjust this a little bit. There we go. So we have the equation, y plus 4 equals negative 1/3 x minus 2. So I also think it's just as easy to graph from point-slope form as it is slope-intercept form. Right? All we have to do is pull out the slope and the point. Now this is a perfect example to point out, if you couldn't pull out the slope and the point from this equation, and you went all the way down to slope-intercept form, what you'd wind up with, you'd have y plus 4 equals negative 1/3 x plus 2/3. I distributed the negative 1/3. Subtract 4 on both sides. We'd have y equals negative 1/3 x. So this would be 12/3. So we'd have minus 10/3. Now, most of you would estimate where this is, but we cannot accurately figure out where the y-intercept of negative 10/3 would be. You'd be guessing. Whereas look at all the points that we used on this line. They're all well defined, right? They're at grid crossings. A negative 10/3 would be an estimate somewhere in between lines. Okay, that's another reason why we need to be able to pull out the information from an equation in point-slope form. To build off that, Now they're asking us to write the equation of the line below in point-slope form. So as we can see, we don't have a well-defined y-intercept. We could take a guess as to what it is, but it would be just that, a guess. So pick any of these points. So I'll pick this point here, which is the point 1, -2. Okay, so our point is 1, -2. Our slope between 2 points. So we go up 1, 2, 3, to the right 2. So our slope is 3/2. So the equation of the line would be y plus 2 equals 3/2 x minus 1. Now I went right to reducing it to y plus 2. Just in case that wasn't clear, it would be y minus -2 equals 3/2 x minus 1. Now let's say you tried this example on your own before I had done it, and you chose this point, or you chose this point. Those equations would be correct as well. All right, so to write those out, just so you can see what those would look like, using this point in purple, that would be, so what's that point? -1, -5. So that would be y plus 5 equals 3/2 x plus 1. And using this point right here, which is the point 3, 1, that would be y minus 1 equals 3/2 x minus 3. Okay, so it's kind of interesting to see how a single line, in this case, right, this is 3 different equations, and we could keep going if we found more points on this line. But at the end of the day, if we simplified any of these equations, we would get the same thing every time, right? They would all match up in slope-intercept form. Hey, but the focus of this video is point-slope form, identifying the point, identifying the slope, creating the equation given a point and a slope. So it's really important, and I also think it's much easier to write the equation of a line in point-slope form. All right, so get your practice in and feel confident with point-slope form.